Hello guys, welcome back to the channel. In today's video, we are going to get started using TypeORM with MongoDB and TypeScript. In today's video, we will cover the following talking points. We are going to look at installation and project setup. We will set up a basic TypeORM project using TypeScript. Then we will set up the connection to our MongoDB database using TypeORM. We will create a basic entity and see how MongoDB entities work in TypeORM. Then we will run some CRUD operations, and this will be limited to creating a single record, creating multiple records, fetching a single record, fetching multiple records, updating a record, and deleting a record. Okay, so if that makes sense, please leave this video a like, subscribe to the channel so you can get access to all my videos in the future as they drop. So let's dive into what we have for today. TypeORM is a JavaScript ORM built to run in the browser, on the server as NodeJS, and pretty much any other place you can run JavaScript. As an ORM, TypeORM allows us to interact with our database programmatically. So let's go ahead and create a new project with the following command. To do that, we'll need to open up a terminal and navigate to our projects directory. Then we'll paste in the command we just copied from TypeORM. We'll modify the project name and the database type to be MongoDB. We'll wait for the project to finish setting up, and then we'll navigate into the newly generated project and open up the project inside of VS Code. Let's open the data source file. It is inside this file we define our database connection, and you can see that we already have some existing pre-configurations. We'll create a .env file where we'll store some secrets like our database URL. We'll add a new env variable, the DB URL. It should be equal to the URL for our MongoDB instance. Then we'll set the URL property to be equal to process.env.db URL. We'll remove database property and add a require.env.config to ensure that all our environment variables are loaded in our application. Make sure to install .env from npm for this to work correctly. Now let's see how entities work in TypeORM using MongoDB. We have deleted the default entity that comes with TypeORM when you create a new project. Let's create an entity from scratch. To do that, we'll create a new file named projects.ts. We'll export the class from inside this file named project. Then we'll import a bunch of decorators from TypeORM, starting with entity. The entity decorator marks a class as a type of document to be stored in the database. The class on which this decorator is applied will serve as a schema for that document, while all documents created from this entity will belong to the same collection. We will decorate the project class with the entity decorator. This decorator accepts a config object. We can use the name property to customize the collection, and in this instance, I'm going to set the name of this collection to be projects. Then we'll import object ID column and column from TypeORM. Since MongoDB uses object ID for its primary key, we'll use the object ID column to decorate the ID property on this class, while we set the type of this ID property to be of type object ID, which we will import from MongoDB. This ensures that MongoDB treats the _ID property as the object ID for each document in this collection. We use the column decorator to decorate the title property, the description property, the price property. Then we'll set a status property on the entity to be of a narrowed type, which we also decorate with the column decorator. Then we import two more decorators from TypeORM, created date column and updated date column. The created date column decorates a property to be the field for when the document was created, while the updated date column decorates a property and the entity to correspond to when the document was last updated. Thus, we'll add two more properties on this class. First, a created art property and an updated art property. The created art property stores when the document was created, while the updated art property stores when the document was last updated, while ensuring that we use the right decorators on each of them respectively. Now we'll create a service class which we will export from a file. This service will contain the methods for interacting with our entity. So let's go ahead and create a new file inside of service / and that file is going to be named projects.ts. Inside of this file, we'll first import the project entity we just created. Then we'll export a new class, project service class, from this file. We are going to add a new method on this class, and this method is going to be named createProject. This method will accept a single argument, which is an object. We are going to compose the type for this object by using the pick utility type, which is provided by the TypeScript compiler by default. We'll pick the title property, the description, and the price from the project entity. Now, inside of this createProject method, we will create and return a new project by returning a call to app-data-source, which we can import from the datasource.ts file. Then we will chain a call to Mongo Manager, which is just a way for dealing with Mongo entities in TypeORM. We'll also chain a call to create on the Mongo Manager. The create method allows us to create a new entity, and it accepts two arguments. The first is the type of the entity we want to create, while the second is an object that contains some values we would like the document created from this entity to have. In this instance, the document would have a title property, a description property, a price property, and a status property. I'm going to create a new method on this project service. This method is going to have a name save. This method is going to allow us to save a project entity to our database. Then we'll wrap the snippet for creating a new project with a call to this.save. This ensures that all new documents are automatically saved to our database. Let's navigate to the data source file, and inside of this file, we'll import the project entity and ensure that we pass it to the entities array with the config object we use to initialize our database configuration. Then we'll navigate to the index file, and inside this file, we are going to initialize our database connection first. Then we are going to console log connected to the database if we successfully connect to our MongoDB instance. Then we'll create a new project. To do that, we first need to create a new instance of project service. Then we'll call create on the project service and pass in an object literal with a type property, a description property, and a price property. I'm going to go ahead and console log the newly created project. I already have this dev script I've set up using NodeMon. And if I run npm run dev from the terminal, you'll see that first we get connected to the database. Then you can see the newly created project document, which is logged out to the console. This document has an ID property, which is of type object ID, a created art, and an updated art property, okay, matching the description for our document. You can see that it also has a price. You can see it also has a title, a description, and a status. So let's go ahead and add a new method to our project service class. Okay, so this method is going to allow us to retrieve all the project documents that have been created. So inside of our service project.ts file, we are going to add a new method named getAllProjects, and inside this method we'll return a call to app-data-source.mongomanager.find and pass in the project entity as the first argument to it. This function also accepts an optional argument, but for now we'll accept an optional argument in our getAllProject functions. This optional argument will have a name limit that limits the number of items to fetch. The find function accepts a second optional argument, just like I said, which is a config or a query object. We'll set the tick property on this query object to be the limit argument we'll pass into the getAllProjects function. Let's go back to the index file and use this method we just created. First, we'll comment out the existing code for creating a project. Then we'll retrieve all the projects we've created by calling the getAllProjects method. Then we'll console log the project variable and start up our project again. You can see that we get an array of projects in our terminal this time. So let's head back to our project service file and add a new method for retrieving a single project. This method is called getProject, and it accepts a single argument ID, which is the ID of the project document we want to retrieve. Inside of this function, we use the find method on Mongo Manager. This method returns only a single document that passes the where clause we pass to the query object. We will use this getProject method inside our index file to retrieve a single document. Then we'll console log the project document to the console in order to see what it looks like. Next, we'll see how we can update a document. So let's update this project document we just fetched from the database. We are going to set the status of this project document to be accepted. Then we are going to call the save method on the project service and pass the project to it. We'll still leave the existing console log statement just to be sure that the status of our project has changed. If we run this file from the terminal, you observe that the project status has changed, and if we fetch that project again and show it in the console, you see that its status still remains as accepted. So let's go ahead and see how we can delete a record from the database. First, let's open up our project settings file and add a new method, delete. This method accepts a single argument project, which is a project we'd like to delete. We'll return a call to app.datasource.mongomanager.delete1, which allows us to delete a single record from the database. This method accepts two arguments. The first is the entity to which the document we want to delete belongs to, while the second argument is the document we'd like to delete. Let's use this in our index file. First, let's delete all of the existing code we've commented out. Then we'll make a call to project service.delete and pass in the project we want to delete as an argument to it. Then we are going to store the result of calling the delete operation in the variable result, which we log out to the console. You can see that is an object with a delete count, which is equal to the number of items we've deleted, and an acknowledged property, which is true. So if you go ahead and console log that project, you see that its value is now null, showing us that we have just deleted that project recently. And I did talk about how we can create multiple records in the database, but for time's sake, we are going to stop here. It'll be interesting to see how you can figure out that on your own. Okay, so I'm going to add the link to this code on GitHub in the description below. If you think this video was fun, please leave it a like. Subscribe to this channel so you can get access to more of our videos as they drop in the future. And I'm going to see you in the next one.